Good morning, students. In the last class, we are actually looking at this particular problem here, this one. This is the problem given to you, and we are supposed to calculate the H value here. So let's take up this problem and solve it now. So this is the problem given to you, and you are expected to calculate the H here. And here, let me say that water is flowing, and let me change this temperature 36 to 35 to make our calculation easy. I am changing it like this. Okay. Now, in any given internal flow problem, okay, first what you have to do is you have to calculate the bulk mean temperature, TBM. That's what I write it. See, let me show you the data book also. See, in your data book, move to page number 132. Move to page number 132. There you will have internal flow. Okay, there might be a little change in the page numbers as per your edition of the data book. That's okay, but you can refer to the index and come to this internal flow. Right after coming to the internal flow page, you can read this. This is very important note here. The properties are to be evaluated at the bulk mean temperature. What it is saying, so all the formulas that we are going to use now that are there here under this internal flow section should be used at the bulk mean temperature values. Okay, so you should calculate the bulk mean temperature in the given problem. Bulk mean temperature means what? In a given tube, you have T in and T out. The average of these two, TMI means inlet temperature, TMO means the outlet temperature. Okay, so temperature of the inlet, temperature of the outlet, you will take the average of these two, that is mean you call it, then you call it as a bulk mean temperature. So that's what we have to do here. Let's calculate that bulk mean temperature. In this particular case, it is 31 plus 35 by 2. So what is this value? 33. Okay, that's what the bulk mean temperature is. Then in any given problem of internal flow, you have to find out whether the case is laminar or turbulent. Laminar or turbulent. So how do you find it? You find it using the Reynolds number. Reynolds number has to be found out initially. So for finding the Reynolds number, what is the formula? Rho Vd by mu. Okay, also you can write it like Vd by nu also you can write it. So in this particular Reynolds number formula, okay, so you have the velocity given in the question. The velocity given in question is 10 meters per second. So velocity is known, and diameter is given as 2 centimeters. This value is also known. And now coming to nu, it is unknown. So you have to calculate it from the property tables. From the property tables, yet see what I request you, all of you, is whenever you write any property value from the data book, you dedicate a space towards the top right corner of the given page. Okay, so top right corner should be used for taking the properties. Okay, yet so and so temperature, that is bulk mean temperature of 33 degrees centigrade. Okay, let's go to that. For finding the property values, that is especially here what you need kinematic viscosity. For that, where you have to go? You have to go to the properties of the water. Where are the properties of water? The properties of water are way here. See, property values. Go to your index and look at the property values. In property values, you need it for water. Water is a liquid. So it is in page number 30. So you have to remember page number 30 for water. So that's the good practice. Here we go. This is your page number 30. Now, here you can see all the properties of water here. See, the properties of water here are given at what temperatures? They are given at 20 degrees centigrade and 40 degrees centigrade. Okay, you don't have the value for 33 degrees centigrade. If this is the case, what you have to do? Somebody tell me.
Interpolation.
You have to
Interpolation.
do something called as interpolation. You have to go for interpolation. See, I know that most of you must be knowing what is interpolation actually, but still I will teach you what is interpolation for the benefit of completeness. Whoever are not aware of it also can learn it easily here. So what I want here is I will take the values of 20 and 40 because 33 is in between 20 and 40. I will take this 20 and 40 values. And what I need is kinematic viscosity value. So these two values I can take. Here it is kinematic viscosity. It is in meter square per second. Okay. So let me take these values here. So for 20, the value is 1.006 into 10 to the power of minus 6. And for 40 degrees centigrade, the value is 0.657 into 10 to the power of minus 6. And you need it for 33. What is the value you want? Okay. So how to do the interpolation? See, whenever you do the interpolation, you have to take whatever you want on your left hand side. When it comes to the left hand side, whatever you want, you can take. There is no problem at all. That is, this side I will take it like 40 minus 33 by 40 minus 20. This side I will take whatever I want. Okay, you can take 33 minus 40 by something minus something by something minus something. You have to write on the left hand side. Okay, left hand side, it is your wish. You can write anything. Okay, it is your wish. Okay, on right hand side, what you should do? On right hand side, okay, follow left hand side. Okay, so whatever you have on the LHS expression, the same values you write it on the right hand side. So corresponding to 40, what you have here is 0.657 into 10 to the power of minus 6 is common, so you can multiply it at the end. So so to simplify it, let us not have it here. Let me call this value as x, which is unknown to be calculated by um, corresponding to 40, the value is 0.657. Corresponding to 20, the value is 1.006. So in this expression, the only unknown is x. So you will be in position to get the value of x. Somebody calculate and tell me fast. What is the value of x? Yes, please. Yeah, please calculate and tell me. See, this kind of calculation, so many things you should be doing in very less amount of time in the examination. So keep practicing it. You'll be doing it. Otherwise, without practice, it will not be possible. With the practice only, you can do it.
0.78.
0.78 into 10 to the power of minus 6 meter square per second. So let me write it here. Nu is equal to 0.78 into 10 to the power of minus 6 meter square per second. So now I'll calculate the Reynolds number value. The Reynolds number is equal to V is 10, D is 2 centimeters, 2 into 10 to the power of minus 2 by new value. The new value is just now we have found out 0.78 into 10 to the power of minus 6. Now tell me what is the value of Reynolds number?
256410.25.
Can you please repeat it?
Two five six four one
2510.25.
zero point two five.
Right. That is your Reynolds number value. Now, can you tell me whether it is a laminar flow or a turbulent flow?
Turbulent.
RE is greater than 2300. What is the meaning of it? If RE is greater than 2300, move to your internal flow page. If you move to your internal flow page, you can see for laminar. For laminar, he has written that the RE value is less than 2300. It is there in your data book. Okay. Next, let's move to the turbulent. It is on the other page. Okay. The page number is 133 here. So here you can see the turbulent. In turbulent, the Reynolds number is greater than 2300. So that's how you will take. You can remember it. Even if you forget sometimes, you can refer to the data book and then recall it. So since RE is greater than 2300, so it is a turbulent flow. So once you know that it is a turbulent flow, how you go about calculating the H value? How to calculate the H value is the key here. So for getting that, what you have to do is you have to move to the data book. In data book, you have to use the formula that are there here. You have various formula here. You have F formula. F means the friction factor formula. So this won't help you. The friction factor formulas won't help you. What formulas will help you is Nusselt number formulas will help you. Why? Because Nusselt is equal to HL. So here it is HD by K. HD by K. Okay. So because it has H in it, Nusselt number will be helping you to um, find out the H value. So that's the point. See, in general, what you have to do is you have to take this case 2.3.1, that is fully developed flow case. If nothing is mentioned in the question clearly, you will consider that it is a fully developed flow case and you will make use of Dittus-Boelter equation. And using this equation, you will be solving the given question. Okay. So what is this Dittus-Boelter equation? Can you see it? Let me write that Dittus-Boelter equation here. The Dittus-Boelter equation is Nu is equal to 0.023 into Re power 0.8 into Prandtl power N he has given here. Okay, N means 0.4 for the heating, 0.3 for the cooling. Here in our case, whether you take it for heating or cooling, tell me in our problem. See, it is
Heating.
entering with 31 and leaving with 35. So it is a heating case. So N, what you have to take? You have to take N is equal to 0.4. Okay, that's what the Dittus-Boelter equation is. Okay, in this equation, RE, you have already found out RE, you have it with you. Okay, coming to Prandtl, you don't have it with you. You have to calculate it. So how do you calculate it? You have to calculate it from the data book going to the property values. See, the easy thing with the Prandtl number is that it's directly available to you in the data book. Can you see this? Here, you have it in the data book directly. So the Prandtl number formula is Prandtl is equal to mu Cp by K. Okay, all mu means nu by rho is here, or you can write it like nu by alpha also. This is alpha, and this is nu here. This by this, if you do, you will get this value Prandtl number. Anyways, it is available to you directly, so you need not to do all these things separately. So directly interpolate and tell me what is the Prandtl number formula. See, all the interpolations you don't try to do in the actual page. You do the interpolations in your rough page. That is enough, because we are doing it for the first time. I am showing it here. From the next time you will do it and tell me. I will not be doing this interpolation here. So for finding out the Prandtl number, so you have the 20 value as 7.020 and 40 value as 4.340, and you need for 33, what is it? It is x, let us say.
5.278.
Yeah, thank you. 40 minus 33 by 40 minus 22 is equal to 7. No, this is not 7. 40 means 4.340 minus 33 means x by 4.340 minus 7.020. It is not 22, it's 20 actually. Right. So tell me, what is x value?
5.278.
5.278. Make sure the value is in between these two. Okay, that's the way you cross check actually. So that's the Prandtl number value. Now that you've got the Prandtl number value as 5.278, write that value here. 5.278. See, this one is enough in the examination. All your interpolations are not required. Interpolations you can do in your rough work. This is written on the top right side page. That is more than enough. Now, since you have this value with you, the Prandtl number value with you, you can easily calculate what is there on your right hand side. In this expression, the right hand side, you completely know it now because you have calculated the Reynolds number, Prandtl number, right hand side is completely known. Coming to the left hand side, okay, coming to the left hand side, you have Nusselt number here. This Nusselt number formula is HD by K. This is the formula. In this one, H is unknown anyways. Okay, D is known to you. The D value is given in question as 10 centimeters or 2 centimeters, I guess. Okay, it is given. K should be taken from the data book again. Okay, so you have to make use of the property tables and do it. So here you have K value for water at 20 degrees and 40 degrees centigrade. So again, you have to interpolate and get the K value now. The K value, you have to find out. For 20, it is given as 0.5978. For 40, it is given as 0.6280. For 33, you have to get it. X. Do it fast. 40 minus 33 by 40 minus 20 is equal to 0.6280 minus x by 0.6280 minus 0.5978. X value, tell me. What is the
0.6143.
one? What is that?
0.61.
6
6174.
one 7 4. Okay, that is your X value 0.6174. You write it here 6174 watt per meter Kelvin. That is the K value. So you substitute that K value into this now. So here you have this Nusselt number. In this Nusselt number, you know D, and even K is also known to you. So what I'll do is I will directly write this HD by K is equal to 0.023 into RE power 0.8 into Prandtl power 0.4. I will write, and then in the place of H you will put H because it is unknown. The diameter is 2 into 10 to the power of minus 2. The K value just now we have found it out. What is that? 0.6174. Am I right? K value 0.6174. That is the
Yes,
K
sir.
value just now we have found out for the water. So that is substituted here on the right hand side 0.023 into RE. Somebody tell me what is the RE value that we have found out?
25641.
25641
0.2.
0.2. That is RE value. Good. Prandtl value is, what is the Prandtl value? 5.278. Okay. So in all this equation, H is unknown. You will calculate it. Tell me what is H. This is power
2933.
0.4. Prandtl power 0.
29335.7.
29335.7 watt per meter square Kelvin is your H value. Okay. So is it clear? See, this is how we will solve a problem. Finding out H is key. Once you find out H, you're done. It's quite simple. Any doubts you have, please ask at this level. See, kindly remember that you need not write the interpolation in the exam. This is a rough work. This is a rough work. Okay, do it in a rough page at the end in your examination. All this is a rough work. Don't do it in the actual question. Don't do it in the actual question. This is rough work. All this is a rough work. So keep that in mind. Right? So is it clear? You have any questions? Please do ask, or we'll move forward. You don't have any question? Shall I move forward? This is your question. That's why I'm showing it here. Right. Let me move forward to next problem. The next problem. Let us take it from here. It's updated in your Google Doc. You can refer to. All right. This is the question here. See, any given question in this particular internal flow problem, first you have to find out it is internal flow problem. Okay. It is flowing through a tube. It is given. It is flowing through a internal tube, internal diameter tube. It is given. So you will understand from this word that it is an internal flow problem. Okay. Once you understand that is an internal flow problem, what is the next thing to do? You have to make use of mm, this one, the data book, and you have to go to this one, the internal flow one. Where is this internal flow? Full screen. In internal flow, you have to calculate the bulk mean temperature. This is the first thing that you should do. So, how to find out the bulk mean temperature? Bulk mean temperature, T bulk mean will be equal to T in and T out. See here, what is given? 325 he is given, 375 he has given. These are the two temperatures he has given. But let us read these temperatures carefully. Write what is given carefully. See here, he has given the rate. So here it is giving in kgs, so you have to call it as mass flow rate. It is 75 kg per hour. It is given. Okay, that is the mass flow rate, and then it's also given that measurements indicate that at a particular point in tube, the pressure and temperature of air are 1 bar and 325 respectively. See, he is giving that pressure is 1 bar and the temperature is 325 Kelvin. So, and the tube wall temperature, T wall is equal to 375 Kelvin is given. Okay. Make the calculation for the heat transfer rate from the 1 meter length in the region of this point. So length he is giving you as 1 meter, and he's asking you to calculate the Q value. See, how do you calculate the Q value in case of convection? In case of convection, you will calculate Q is equal to HA delta T you will use. Okay, in this delta T is given in question. A can be calculated using this L, but how do you get H? You have to make use of some correlation to get the value of H here. Okay, that's how you will find out the Q value here. So, what will be your bulk mean temperature in this question? Can somebody tell me? What is the T bulk mean? Yes, please respond. This is what.
325.
Which one will you take?
325.
It is 325. Very good. It should be only 325. See, most of the times while this kind of thing is given to you, most of the students, what they will do is they will take the average of these two. That is 325 plus 375 by 2. They do. This is absolutely wrong. Okay, because in T bulk mean the formula is for the fluid only, temperature of inlet fluid plus temperature of outlet fluid. Okay, in bulk mean temperature, you are interested only in the fluid temperature, only fluid temperature. Here, what is given to you as 375 is a wall temperature. So wall temperature should not be taken as a fluid temperature. This average should not be taken like that. Okay. So this is very important thing to find. Many students confuse here. Sometimes this value is given as one value. So the bulk mean temperature that is given in question is T bulk mean according to the question is 325 Kelvin. Okay. So let us take it in degrees centigrade itself. So the temperature is equal to 325 minus 273. What is the value?
52.
52 degrees centigrade. This is the temperature value for air. I tell you, see, the properties are to be taken for air. Air is given in question, right? So you take it for air and keep this at right side corner of your page, and you'll be writing all the property values here in this place. All right, let's keep it aside. And what is the next thing to do? Okay, what is the diameter given in the question? It is given as 10 centimeter internal flow. It is given to you. Okay, so you take it. The diameter also must have written here, 10 centimeter. Okay, now once you know the bulk mean temperature, what is the next step here? Next step is laminar or turbulent. Laminar or turbulent, you have to find out. So laminar or turbulent, how will you find out? Reynolds number.
And all.
It is Vd by nu. Okay, so this is the formula. Do you have V with you in this formula? In this particular question, he did
Mass
not
flow
give you V. He has given you m dot. What is the relationship between m dot and V? M dot is equal to rho A V. The A value is here pi by 4 d square into V. This is a cross-sectional area you have to take here. Okay. See, the simple thing to do here is, anyways, you can do this way also. But what I tell you is, there is a formula called 4m dot by pi d mu. 4m dot pi d mu. This formula is also there for the Reynolds number. You better remember this formula. I think it should be given here. Yeah, it is there in your data book. Okay, on the first page, that is page number 132. Towards the right bottom, if you see, you will have this 4m dot by pi d mu formula also. But this m is taken in kg per second. That should be taken care. Here it is given as kg per hour here, converted into meter per second and substituted here. So m dot value is, what is m dot value? 75 is given in question. So substitute that 75 here. Kg per second you need it. So what you do is 1 by that hour you convert into second. That is 3600 second. 1 hour is 3600 second by pi d value. What is the d value? It is given as 10 centimeters. So 10 into 10 to the power of minus 2. Let us take mu value you need here. Do you have the mu value with you? This mu value, you don't have it with you. So you have to go to the data book and then calculate the mu value for air. So where is it in the data book for air? So this is for water. This is for ammonia. Go to page number 30. Keep going till page number 40, I guess, or 42. Till you find air, you go. These are various things. See here, you have it for air in page number 42. These are all the property values of air. Dry air is written here. And all these property values are taken at 1 atmospheric pressure. That's why in the question, he has given you the pressure is 1 bar. The pressure is 1 bar is given in question. That is the reason. Even if it is not given also, by default, you have to take it as 1 atmospheric pressure only. You have to take it. Okay. So that's how the air values are taken here. So what is our temperature here in the question? Bulk mean is 52. Here you have it for this problem, you have it for this data book, you have it for 50 and 60. So 52 is in between these two. So make use of these values to find out the mu value. So the mu value is given in the second column here. So you have to make use of these two values and calculate it. So let me go down here for calculating the mu value. 50, you know, it is 19.61 into 10 to the power of minus 6. 60, you know, it is 20.10 into 10 to the power of minus 6. And then you have to calculate it for 52. What is the value? How to get? So do the say do it fastly and tell me. I need not do it every time. Okay,
19.7.
let me complete this. 19 point, yeah, please.
708 into 10 power
708 into
6.
10 to the power of minus 6. This is your rough work. This is your rough work. I'm showing it with a different color. Understand? Right. So let me try this 19.708 in this. The mu value is 19.708 into 10 to the power of minus 6. What is this? This is taken in mu. That is the dynamic
Newton second
viscosity.
per meter.
Pascal second. You can write. Okay. Or Newton second per meter square. Both are same only. Uh, so once you know this mu value, what you have to do, you have to substitute it here. It is 19.708 into 10 to the power of minus 6. From this, you will get what? Value of Reynolds number. Tell me what is the Reynolds number value? Yes, Reynolds number value.
13459.4.
13459.4 is your Reynolds number value. So this Reynolds number is well above 2300. So obviously the flow will be a turbulent flow. Therefore, the flow is turbulent flow. Once you know that it is a turbulent flow, what is the next step to do? You have to go to the data book. In the data book, go to that particular page number, the page number 130, and then you go to the turbulent formulas. These are the turbulent formulas here. And in the turbulent formulas, you have to choose the appropriate one. Here is not given any shortcut and all those things. So obviously, you have to go for the fully developed flow Dittus-Boelter equation. Write the equation and solve it. Right. In the question, whether you have to take 0.4 or 0.3, how do you decide in this particular question? Is my question clear?
Cooling.
Cooling. Yeah? How can you say that it is cooling?
Heating, sir.
Heating. How can you say it is cooling? Heating.
The wall temperature is higher now.
The wall temperature is higher. See, the temperature of wall is 375 and the fluid temperature is 325. So kelvins are given. Heat flows from the high temperature region to the low temperature region. So the fluid will get heated up. Fluid is getting heated up. So based on that, you can say it is a 0.4 only in this question. So you know what is the Reynolds number value on the right hand side. You don't know what is the Prandtl number value. So you have to get the Prandtl number value from the data book again. So go to the page number 42 at 52, calculate the value of the Prandtl number. So here it is. You have to make use of this 698 and 696. Calculate it. The Prandtl number is 50, it is 0.698, and 60, it is 0.696. Unit with 452. Let's card as x. 60 minus 50. No, 60 minus 52 by 60 minus 50 is equal to 0.696 minus 0.698. Sorry, this is amount. 0.696 minus 0.698. The value of x, you tell me.
0.6.
0.694.
0.68.
7. 6976
69.
64.
76.
Is it right?
Only 76, sir.
Only 76. Right. 6976 is the Prandtl number value. Again, I am reminding you, this is your rough work. This is rough work. Not do it in the exam in this one. So the Prandtl number value that you got, you write it on the right side corner of your page. This is the table value, property value that you got. 0.6974 or 79. What is it?
679.
76.
76. Yeah. That is a Prandtl number value. So now we are done with the right hand side of your Dieter's-Boelter equation. You need it for the left hand side. On the left hand side, you have HD by K. H is known to you. Sorry, H is unknown to you. You have to anyways calculate it. D is known to you. The K should be taken from the data book. So again, you go to the data book. In the data book, the K value must be given to you. So the K values are given here 0.02826, 0.2896. Using this, you have to do the interpolation for 50 you have, and for, for 50 the value is 0.02826, and for 60 the value is 0.02896. For 52 you have to calculate, it is x, and then it is 60 minus 52 by 60 minus 50 is equal to 0.20286 minus x by 0.02896 minus 0.02826. So the x value is unknown. Get the value of x.
0.0284. 284.
0.028. 4. No numbers, no more number. That's it. Okay, let's take that x as 0.0284. Again, this is a rough work. This is your rough work. 0.0284. Okay, value is 0.02. Yeah. Watt per meter Kelvin. That is the K value. So you have everything with you now. Simply substitute all the values into Nu is equal to 0.023 into Re power 0.8 into Prandtl power 0.4. So the Nu value is Hd by K. Hd value is given as 10 centimeters, 10 into 10 to the power of minus 2 by the K value. Just now we found it as 0.0284. What is it? 0.0284. That is the K value, Hd by K on the left hand side. On right hand side, 0.023 into the Re value. Just now we found it out. What is the value of Re? Tell me. It is 13459.4. 13459.4 over 0.8. The Prandtl value, what is it? 0.6974 over 0.4. In this only unknown is H. Tell me what is the value of H?
11.37.
11.37 What is the unit of this one? Watt per
Watt per meter square Kelvin.
watt per meter square Kelvin. So that's how you find out the H value. But he's not asking the H value in the question. Actually asking you what is the Q value in the question. So how do you calculate the Q value? Q is equal to H into A into the delta T. That is the temperature of the surface minus the temperature of the fluid. Remember this? Whenever you use the delta T in HA delta T, it is one temperature is of the solid and the other temperature is of the fluid. Both are not of the fluid. Okay, that should be kept in mind. So what is the T? Yes, you are here. It is given as 375 in question. T fluid is given as 325 in the question. Kelvins is meant. Okay, so these values you can substitute there. How about area here? What is the area formula that you should take here?
2 pi RL.
Surface
Huh?
area
If you have
interacting,
a
pi by 4 d square into L.
it is not pi by 4 d square into L. It is this area. See, if this is the tube here, the fluid will be flowing throughout here. Okay, throughout here, it is flowing. It is not flowing only this one. This one is pi by 4 d square. Okay, this is not the one that you should take. This one you have to take. This one and this one. So what it is pi d into L or 2 pi RL, anyone you can take. So it is pi dl. See, the area is very key issue. Learn the area properly. Area with which the fluid is interacting. Area is interacting, fluid is interacting with this whole area. Inside the tube, if it is flowing, means it will not interact only here. It will not interact throughout the length. That is pi dl. Pi by 4 d square into L is the volume. It is not area. All right. So pi dl, you substitute and calculate it. So the Q is equal to the H value. Just now we have found it out. It is 13 point. What is it? 11.37.
178 point
11.3.
watts.
The area value is pi into D values are 10 into 10 to the power of minus 2. The L value is given in question. The L value is given in question or not? Yeah, it is 1 meter given in question. Let me write that 1 meter here. So all this is the area into
178.5.
you are directly telling the Q value, right?
Yes, sir.
Yeah, tell me what it is. What?
178.6.
178.6 watts. Isn't it? Watts
Yes,
again
sir.
will calculate. Yeah. So this is the right answer. So the Q value is 176.8 watts. That's how we get the Q value. So with this, I will complete it for today. So please do attend the classes in the afternoon. Okay. So they are very important to you.